This is section 2.8 from Algebra 2. We are going to graph inequalities. Our objective is going to know the difference between an equation and an inequality and how to graph an inequality. Alright, so what we need to go back and we need to remember is that there are two main forms of an equation that we use for a line. The first one is our slope y-intercept line, our slope-intercept form. Remember, that's the y equals mx plus b. Second form that we really use is the standard form. Remember, that's the ax plus by equals c. Each has its advantage in different times, and you may like one better than the other. Make sure you know when to use which one and which one is which. So what is an inequality? Well, remember, what an inequality is when we have infinite solutions, and really we're only basing it or comparing it to one number. So an example of an inequality is x is greater than 3. Now, we don't have only one answer because there's a lot of numbers greater than 3. In fact, there's infinitely many numbers greater than 3. There's also ones where we have negative 3 is less than or equal to x, which is less than 4. Remember, those are compound inequalities. Now, even though there are few whole numbers that are between negative 3 and 4, there's infinitely many non-whole numbers that are in between there as well, or non-integers. So remember, inequalities are always going to have your greater than symbol, less than symbol, your greater than or less than, or your greater than, or sorry, your less than or equal to. Sorry, I said greater than or less than, greater than or equal to, less than or equal to. All right, so did a little bit of the inequality reviews. Remember, when we graph those, if I were to graph x is greater than 3, I graph it on a number line. There's 3, 0, negative 3, open dot because it's greater than, not greater than or equal to, and you draw the line over. Just a quick review. When we do the negative 3 to 4, so I'm going to put a 4 there, keep my negative 3. We're going to put a closed dot at negative 3. We're going to put an open dot at 4, connect them in. That's your compound inequality. All right, now linear inequality that has two variables. That would be an example of something like 3x plus 4 is greater than y. We have two variables now. Or say something like 3x minus 4y is less than or equal to 16. Again, those are two variable inequalities. They're written in different forms. One's in standard and one is in slope-intercept form. So when we're given a variable an inequality with two variables, we need to know the solutions for that inequality. And really what a solution is, it's a point or a term that works for that inequality. So let's do an example and see if you know what I mean. So if we look here, which of the following are solutions to the inequality? So my inequality is 2x minus 6y is greater than 12. Well, easily, all we have to do is we have to plug it in to check and see if it works. So remember, with inequalities, there's not only one right answer. The way we plug this in is we just plug in our x and our y into the inequality. So I'm going to use 2 and 4 for my x and my y. So 2 times 2 minus 6 times 4, is that greater than 12? Well, 2 times 2 is 4. 6 times 4 is 24. Is that greater than 12? Well, we can already tell it's definitely not. It's going to be negative 20 is not greater than 12. So we know that 2, 4 is not a solution to the inequality. Okay, let's try another one. Let's try up here. I will try 0, 0. I'm going to plug it in again. 2 times 0 minus 6 times 0. Is that greater than 12? Well, we have 0 minus 0. Is that greater than 12? Well, again, we can tell that 0 is not greater than 12. So this doesn't work at all either. Try the last one here. And we plug them in again. So 3, negative 6. So 2 times 3 minus 6 times negative 6. Is that greater than 12? Well, 2 times 3 is 6. Negative 6 times negative 6 is plus 36. Is that greater than 12? I think we can already see that 42 is indeed greater than 12. And because 42 is greater than 12, we know that it is a solution. So another way to find another solution for this pair is just to plug in numbers that work. Now you notice, look at the y that we used that worked. We're subtracting here, so we need a number that's going to get bigger rather than smaller unless we have really big x's. So for instance, I could use, I don't know, 42 is my x and 3 is my y. Well, 2 times 42 is going to get me 84 minus 18 is definitely going to be larger than 12. That's an example of one that works, and there's infinitely many numbers that, or infinitely many points that work. So just choose one that actually works for inequality, and then choose one that doesn't work for that. But I'm going to skip that, and we're going to go on to the graphing part, because this is the big part of this section. So the graphing part, we're going to look at this, and I'm going to pretend like right now this is the same thing as 5x minus 2y equals 6. And I'm going to think about graphing that. We did this already. And the way to graph that is going to be to either convert it to slope-intercept form or do your t-table, find your x and y intercepts. I'm personally going to change this one into x or slope-intercept form, and I'm going to take this, I'm going to subtract my 5y, so my 5x plus 6 divided by negative 2, so I get y equals 5 halves x minus 3. Now if you do your t-table, the reason I didn't do that one for this one, you're going to end up with a fraction that is really hard to graph, so that's why I just decided to use my slope-intercept form. And now I'm going to go and I'm going to graph my points here. First one I'm going to graph is my y-intercept at negative 3, and then we're going to go up 5, so 1, 2, 3, 4, 5 over 2. Let's see, can we make another one on there? Up 5, 1, 2, 3, 4, 5 over 2, right about there. Now, before we connect the dot, or the lines to make our actual line, what we have to look at is our inequality. Remember when we graphed our single inequalities, we had either an open dot or a closed dot. Well, with the linear inequalities, the one with two variables, we're not going to have open dot or closed dot. We're going to have a dashed line like so, or a solid line. The dashed line is when we use the less than or greater than. The solid line is when we use the less than or equal to or the greater than or equal to. So if we look at this, we should be using a solid line for this graph because it is or equal to. So all we need to do now is connect our dots through there. Now we have our line. But that's still not all of the numbers that work. Really, there's just tons and tons of numbers that work. So what I'm going to do is I'm going to pick one test point, and I always like to pick 0, 0 if it's not on the line to be easier. And I'm going to plug that in. So I'm going to test 0, 0. And we're going to plug that in. 5 times 0 minus 2 times 0. Is that question mark less than 6? Well, 0 minus 0, is that less than 6? We all know that 0 is indeed less than 6. So what that proves is that that dot there, that is a solution. 0, 0 is a solution. That means that everything on this side of the line is a solution, and everything on the opposite side is not the solution. So that means we're going to shade in this way. Now you can go and you can test all those points, and I promise you they're going to work. The other way to do that is if you test a point that's not a solution. So for instance, let's test 3, 0. So 5 times 3 minus 2 times 0, is that less than 6? Well, 5 times 3 is 15 minus 0, is that less than 6? Well, we all know that 15 is not less than 6. That doesn't work. So this part is not a solution, and that proves that every single thing on that side is not a solution. All right, let's do another example here quick. And this one is already in slope-intercept form, but right now I'm going to notice something. I'm going to look right here and notice that that is going to be a dashed line because it's just greater than. It's not greater than or equal to. So I'm going to graph my point, y-intercept at 4, go down 2, right 3, down 2, right 3. I'm going to go up 2, left 3, and then I'm going to connect this. And remember, we need to do a dashed line. What that says is that the numbers that are actually on that line will not work, because those numbers on that line will actually make it equal to. So I'm going to show you one that's on there. So we already know that 0, 4 is on there. So let's plug that in. 0, 4, plugged in my y, or my x for my y, is 4 greater than negative 2 thirds times 0 plus 4. Well, we can simplify that side. Is 4 greater than 4? Well, no, 4 is not greater than 4. It would only work if 4 was greater than or equal to 4. So that shows you right there why when it's not an or equal to, that's why we put a dash line, because the numbers on there don't actually equal or aren't solutions for the inequality. So now again, I'm going to put in a test point to figure out which way I need a shade. So I'm going to test, and again, my good old buddy 0, 0 is a point that I can test right there. And so I'm going to plug that in. So 0 is greater than or equal to negative 2/3 times 0 plus 4. Okay, well we have 0 is greater than or equal to 4. Is that true? No, that's not true. 0 is not greater than or equal to 4, or sorry, it's not greater than 4. So we know that this point is not a solution. So I know that everything on the other side of the line is a solution. Now you can plug in some points over there to test them, but I promise you they'll all work. All right, next thing let's graph these points, or these inequalities. So first thing to look at is what kind of graph do we have. So I'm going to remember I'm going to look at this as just x equals 4. Well, remember back from previous chapter, x equals 4, we know that's a vertical line at 4. But now we also have to look at that, our inequality. Is it going to be dashed or is it going to be solid? If it's just less than, it's going to be a dashed line. So we're going to go over to where x equals 4. There's my vertical line. Now again, let's put in a test point, and I'm going to test 0, 0. And we only can put in the x. You can see that we can only put in the x. So let's see, is 0 less than 4? Well, yes, it is. So that means we need a shade towards 0, 0, which means we're going to shade on everything on this side of the inequality of our line. One more for you. Again, y is greater than or equal to negative 2. I'm going to look at it like y is equal to negative 2. I'm also going to pay attention to that inequality. Since it's greater than or equal to, it's going to be a solid line. So we're going to go down to where y is negative 2, and we're going to draw the horizontal line, because y equals negative 2 is horizontal, and it's solid because it's or equal to. Now again, let's put in a test point. 0, 0 is the one I'm going to choose. I know you're shocked by that one. And we're only going to be able to plug in the y value here. So is 0 greater than negative 2? Well, yeah, 0 is greater than negative 2. That means we have to shade above the line here, and we're going to go there. Now, there are some tricks to be able to figure out the ways, but I always like to test the points. That's the surefire way to always know. I'm not going to teach you any tricks. I'm not going to talk about any of the tricks. If you want to look somewhere else to find those, you absolutely can. So that's all we're going to talk about for this section. Make sure you guys take notes, rewatch anything you need to, pause it when you need to.